Hello there guys, welcome back to the e-bike repairs YouTube channel. My name's Dash and I take apart and fix very fun and exciting stuff like this. This is a volt LiPo battery. It is a 36 volt 12 amp hour pack. Teeny tiny little writing there, probably won't focus, but I'm not lying. The customer says it needs reselling, so it doesn't hold its charge properly anymore. There's some more little numbers on the bottom of that for you. So I thought I would crack it open on camera and we'll have a little look at what's inside. So we've got a key switch here, on, off, and it doesn't lock it in place. Only removable when it's in the off position. And then the same key down the bottom pushes out the lock, so the locking pin on here is at the bottom. So it's a bit like a silverfish battery, but a normal silverfish battery doesn't fit because manufacturers make different things, which is fun. My lovely door impact is missing, so I'm using this fantastic tool. So we've got 1, 2, 3, 4 Phillips head screws on the top here to open it up. There's one, nice and long. I'm pretty sure that's these are M4 screws. Over there. 2, 3. They're all the same length on the top, which is nice. And that makes 4. Oh, I smell leaky LiPo cells. So, pouch cells is what I smell. Which is lovely. Lovely. So we'll need to pop off the bottom as well, because there'll be wires that come down to the discharge ports. Same situation. 1, 2, 3, 4 screws. Probably not as long. Oh. Yep, not quite as long there, shorter. 2. 3. And 4. Right, so pop the bottom off there. All stuck down. There you go. Will that fit through that way? Possibly. Oh, it's going to be an arse to get out. So the cells will have swollen inside this package here, and unfortunately that's going to make it really hard to get them out. I don't think that this fits through the profile. Does it? Well, I think it might. So there's not going to be any movement on that because the cells will have swollen inside and squeezed the outside. There's no silicone all around the top, which is lovely. We like that a lot. Hate when there's silicone to absolute boxes. The problem I'm going to have is getting it out of here. I apologise for the background noise, by the way. I've got my ancient air conditioning unit on because it's so hot in here I can barely exist. So what I'm going to try and do is push, using this piece of wood to push the cells up and push them up towards the camera. So we'll have a little look, see if it does anything. Oh yeah, it does. Fantastic. Does that fit through there? Huh. Pop it back down a little bit. Come on. You know you want to fit. It's not going to fit, really. It's not going to fit. Hateful, isn't it? Oh well. Looks like we're taking apart this lower section then. So there'll be, I think, just 3 screws holding this on. Missed my impact driver. It's somewhere, it's in the garage or something. 3 little screws like that. Wood type screws, what are they, ½ an inch long, something like that. Then this plate here will pop up. That holds the lock in place, because now you'll see the lock just a broken bit. Oh, that's good. To glue that back on there. That's come off. Put that in the box. And another broken bit down here. Great. There we go. So the lock barrel now is replaceable if you want to get it out. It would have had screw holes in it. It's just a high long lock barrel, but they're not using the screw holes, it's just held in place with that little plate. That's nice. And we've got a couple broken bits of plastic here. So is this actually from here? It's from the other side. Is that from inside? Well, I don't know now. No, I think that's from there. That is from there, which means what was there? I will refer back to the video and see if I ever even had that little plastic nub. Because, oh no, look, here we are. It's fallen off over here, so a bit of gluing is necessary. It often happens with older cases where they're damaged. So that, oh, there you go. That one back there. That fits on like that, so I have to glue that back in place so it sits properly, and then I'll reinforce the back up with loads of glue after I take the key barrel back out. Be the answer to that. Right, now the cells should come out now because these are loose. I don't think the leads are in any danger of popping out. This side's a bit loose, but it should all be held in place with plastic clips. That's how you replace the pins and stuff. So let's now see if I can push these cells out. Oh yeah, here we go. God. I have swollen right up in there, down the line of that. How much that's bulging now it's out of the case. Don't know how well you can see, but it really does bulge. Yeah, I don't know how well that comes across, but oh, there we are, we're out, we're free. Lovely, so that's our aluminium extrusion. That's at the top, that's at the bottom. It wouldn't actually matter which way up it went, I don't think. Just obviously the sticker would end up upside down, which looks a bit pants. So I'm going to need to cut open the shrink wrap to get these discharge leads out, unfortunately. So I'm not going to be reusing this BMS. But unfortunately, undoing the shrink wrap, of course, allows the cells to puff more. Bit of a shame, but what can you do? There's a piece of fiberboard here that runs the length of it. Great. That should insulate the from the outside. Yeah, fantastic. Let's pop the fiberboard out. Oh, stinky. So stinky. Oh yeah, that is a very, very swollen cell there. Whoa. Smelly. So this is quite the fire hazard, a swollen cell, because at some point it could finish puffing, which is the problem. We actually only have one swollen cell in this, but it's enough to put out the whole pack. I'm not going to be replacing them. I don't do lipo cells. I'll replace with 18650s or 21700s, where possible, of course. So what we've got are, it's hard to see on that, well, these cells. Oh, she's puffy. Oh, crikey. Right. Let's pop this off here. Get a better look in there. Okay, and there's our BMS. Just chilling. So, got our. Let's nip these off as I go, actually. Where are my wire cutters hiding then? Huh? Who's taken them? I think they're in the back of my van. We're going to use these. So, we've got our negative discharge wire. Clip that off. We've got our positive charge wire. We've got our positive discharge wire. And we've got our negative charge wire here. You still in frame? You're still in frame. We're all good. Oh wait, I don't know what that one thought it was. I'll find out. And then we've got our, this will be our charge wire, the yellow one normally. One of those. This is going away, far away. Okay, it wasn't that far away, but it's gone. So, what I'm left with then is this lot. So the yellow was our negative discharge wire. The blue is power up to our battery level indicator that lives on the top just here. And the little red one up here is for the positive on the discharge port. And the key switch itself switches between the, where does that go? We've got a yellow and a red. So the red is in, the yellow goes out from here into the fuse and back out on the long red discharge wire. Definitely not confusing at all. Lots of bits of wire doing all sorts of different things in all sorts of different colours. So to resell this, let's see what we can fit inside here. The customer's happy for it to be 12 ampere again. I accidentally quoted him the wrong price, but that's my own fault. I have to stick with it now, won't I? So let's see what we can fit inside here. Let's grab a couple of cell holders for testing. Oh look, we can get 3p in easily of 8650s. That fits nicely. Could we fit, oh look at that. You could then fit many cells in a long fashion all the way down there. Let's see just how many. I think for 12 amp hour I'm going to have to do 4p of something. Don't know what I'm going to use, but maybe LG M30 or MH1s, there you go. I knew they had a number. MH1s. So here I've got some, what have I got here? Oh look, MJ1s. Oh, nice, shiny. Will I get an MJ1 in? Oh, I think I will. Let me get some more spacers. Loads more spacers on there. Is there enough room to comfortably fit that, plus some padding? You know, I think there is. I think that there is, which is nice, because we'd have that, then we'd have a sheet of fiberboard like that, which would add that much size to it. Yep, plus another sheet of fiberboard on the other side, plus a, yeah, it will be a squeeze. I'll have to run all the wiring down this side here, otherwise it won't go. You know, down the opposite side, they can't go on this end, but they will fit. It's exciting, isn't it? How good. Now, will we get 10S 4p in here, so we'll need 40 cells in the cell holders. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10S 3p, and we just need 4p, so we need to add another 10 cells room to this. So that makes 3 more cells, 6 more cells, 9 more cells. Oh, we've got loads of height to work with. And if we have one more of these, just for ease, that means that we've got more than enough room for all the cells, and look at that, fits with room to spare all our excess wiring and stuff, so the BMS could sit on the top. And it won't sadly be quite as simple now as slapping a, what do you call it? 3p config in, but it's very possible, and realistically, in the scheme of things, it's not that bad. So instead of having a ladder that would just go 1, 2, 3, 4, 5, and so on, to keep it 1, 2, 3p and have the series go this way, I'll probably have to do 4, so 8 cells for a group. So start there, that's the first group, 2, 2, 2, 2, yeah, that will work. Ooh, it's doable. What I'll try and do, as loads of people have asked, is for me to do is show like a RECELL. I will try to film me doing it, sort of a full-ish battery RECELL video, so people can see what goes into it and what's involved. I'll probably edit some bits out, but you know, I'll do that. So hopefully, next thing you're going to see is me, once cells have arrived, because these are for something else, once cells have arrived, assembling the pack. Okay, it's been a few days, cells have arrived, and I started putting them in, and then I thought, oh no, I need to film this, because I don't normally film any of this bit. But here we are. Right, so my thoughts are to make up my 10S 4P pack. I can't go this way because it doesn't fit inside the case, unfortunately, but that's fine. It is what it is. It is what it is. What I'm going to do then is pop the cells in like that. Now I've got some, I had to use up the end of some red cell insulating rings, not green ones, so some of them are mismatched and it will be painful to look at for some of you, but it's got insulating rings, that's what's important. The colour actually doesn't matter. So I'm going to start off here, so 4, 4, 4, and then I'm going to work my way sort of that way, like that, and then they'll go to like that. And this will be the simplest way, and then I'll be able to use some nickel ladder to join them all together. And using ladder is great because it's a lot less individual connections to join up. So I could go that way along the pack, but what I'm going to do is use ladder and go that way. So one connection here, one connection here, one connection here, and then join on the back, and then it'll make sense when I start doing it, I'm sure. Once I get the nickel cut. Then we'll have 4 random ones. Aren't going to be quite the same as all the others, and they'll just be in this space here. So we're going to go that way, that way, that way. 1, 2, 3, 4. A little bit like that. There are optimum methods for connecting cells, so you know, to keep the same amount of series connections throughout them all as you go. In this case, it's a little 36-volt battery for a 250-watt straight legal e-bike. That realistically, what's going to pull max 800 watts peak for a very short amount of time. It should be absolutely fine. Even if we're not using the optimum method, because here we're only going to have a one. Well, in some of the joints, we're only going to have a 1p. A single series connection, as opposed to the others we're going to have 4. But I could double up the nickel strip there and it will work absolutely fine. So on higher power packs, you want to start looking at how you do that a lot more and keeping them even. But of course you also have to work within space constraints, so it's not always that simple. So for this then, I'm going to join these 4 up here, which means I want the other lot of strip, not this one. This is the strip for joining cells without holders. Okay, like that. And to cut it, I just use my pair of scissors that I've lost. Bear with me. There they are. They were just hiding. So I'll get rid of these tabs and cut one of those. So that's going to go on there like that. Nice and simple. You can trim the end of these corners if you're bothered. You also don't have to if you don't want to. Depends how you build the pack. Of course, technically, a large impact could short the side of the nickel strip here to the cell. However, it's such a tiny, thin part of strip that you're not going to... The chances of anything bad actually happening are incredibly slim. So we're going to join here, this side, and then they'll be joined, then they'll be joined, and then they'll join on the other side, and then they'll be joined, and then they'll be joined to that. Yep, that makes sense to me. It'll all make sense. Hopefully. Anyway, I'm a terrible teacher. It's one thing I've realised. Teaching is not my forte. It's not what I'm meant to be doing. Oh no, look, it doesn't even go like that, does it? It goes like that. Because we're going to join you to there. Pos to neg, pos to neg, pos to neg, pos to neg, pos to neg. My brain is hurting. Pos to neg, pos to neg, pos to neg, pos to neg, pos to neg. Yeah, no, it makes sense. So this one, we're just going to want a 4. I suppose I could make it... No, I'll just make it a 4 square. Or do I want it to be... What way do I want my connections to come out for them? That. It won't matter. Good stuff. And here I'm going to leave this tab attached so that I can make my connections here. That'll go like that, and then what we're going to need is a piece of a long piece of nickel to go across there. And a second one, because we're going to double it up, otherwise all the power's running through that tiny little strip. And then for this end, I'm going to want to do the same with one of those. Like that long. And one of those up to about that long. So, I'm using my do create, I don't know how you say it, little capacitor spot welder. It's just so effortless to use. Leave it to charge up for a while, then you can start popping spot welds in. The probes will get hot, but that's fine, as long as you sort of manage your time well in using it. Okay, just touch the probes, and there's 1, 2, 3, 4, 5, 6, 7, 'And what happens with this spot welder is that the probes get warm, but also the voltage of the capacitors drop down. And once you get past sort of 4.7 volts, it doesn't really give a very good weld anymore. So at the moment it's a lovely strong weld, and you can't peel the nickel off very easily at all. You've really got to tear it off, which is good. That's what you want. You want a nice strong connection. And what it will do is when the capacitors drop down, it just sort of, you've got to wait for them to recharge, otherwise you get a pants connection out of the thing that doesn't really do it any good. And then you're building a weak battery that, you know, if you don't want a piece of nickel strip to come off, because best case scenario, you've got to fix it. And you look silly because you made a battery that doesn't work. Worst case scenario, of course, is a battery sort of, you know, a thermal failure, shall we say. Go. So we're already down to 4.9 volts. It doesn't do that many welds without needing the capacitors to charge. So you've got to, you know, leave them to charge for a bit. However, for a small pack like this, it's so convenient. You just sort of turn it on, 20 minutes, half hour before you want to start welding. Leave it, and you're ready to go. And the thing I like the most about it, as long as you let the capacitors be at a similar voltage, it just leaves consistent spot welds every time. So the probes are starting to get hot and burn my little fingies now. Great fun. And this one, I don't want to put this on yet until I've got my series connections on. So we're down at 4.8 volts for the capacitors, so I'm probably going to have to walk away for 5 or 10 minutes and let it charge up, because welding this stuff is a lot easier for the spot welder because it's got the slot cut into it. And welding solid strip like that isn't as easy because you've got to I think the energy travels through the nickel more, and if you're going through the slot, it travels through the cell more and gives a better weld easier, something like that. That's the way I understand it anyway, so I'll cut back in a minute. Okay, it's charged back up now. The maximum voltage on it's 5.2 volts, and that's charged up again now, so should be good to go. Put some grease on that. Great. You can see when it is charged up, you get a way better weld out of it. So when you're using the ladder, you can run it down more, but when you're doing the solid strip, it doesn't like it that much. I think this is 0.15 strip thickness. So 2 of those doubled up will be absolutely fine for this little battery. That, and then we're still at 5 volts, which should be enough to weld what is essentially a third piece of nickel on top of these 2 connections for my ladder here, which is just an easier way of connecting up what's the cells I've got. You could of course cut regular nickel and use it, but I've got ladder and I'm going to use it when I can because it's quicker and it's easier. And it makes me life better. Nice and solid there. Lovely. And then we've got our, hopefully I got a second one of these, I did, two slightly longer pieces of nickel here. One's going to go along like that, and the other one on top of it. Then I'll take my very thin nickel here, and that's just to do the balance wires with, or the balance tabs, should I say. There we go. Probes are getting so hot I can barely hold them. But you can see it's painless. You get consistent spot welds throughout. I do think it's a decent welder. So I've got to do my balance tab. So we've got one for this group. We'll need one for that group, one for that group, one for that group, and one for that group. As I'm facing this way already, I'll probably just do some of these. Ideally, I try and only have them on the negatives, but I can't in this case, so I will have to pop some across the positive connections here. And snip them off. They don't need to be very long. There you can see my red cell insulating rings. I had 7 left, I think, and I thought, oh, I'll just use them up. I have to use them up at some point, and what better place to use them up than somewhere where it will annoy people on the internet. Flip that round. So we've already got our one for this group because we built it into the ladder. It's one less connection to make up manually. Saves time, saves effort, saves money. And then we've got one to do here. Where should we pop it? Should we pop it in line with that one or over here? Let's go over here. We're closer. It's nice to get them near the middle if you can. I don't know why it matters that much, but it's nice to. Now the space we're working with in this pack is very limited, so a worst case scenario for this, I have to move this over and move this to the end, and then wrap the wires all the way around the pack or something. Be my thoughts there. So what I'm going to do now is we're going to have our main negative connection that's going to be here but on the reverse of this. Then we're going to join these two together with a piece of ladder. Let's cut one off so I can show you. Ignore the tabs, they're just in case I want them in a sec. So we're going to join them together like that, and then like that, and then we'll have a long one, and then we'll join together like that, and then this will be our positive on the other end of this pack here, group, sorry. So that's our negative, which needs to be by itself, and I'm sure because we're limited space-wise, I'm going to have to bring the tab for the discharge tab over this end. So what I'm going to do is spot weld this on, but keep this long, and then I'll get some extra length and I'll fold it back over and spot weld it on itself. So I want to get a bit of extra length, like, I don't know how much, but that much should be plenty. And then I'll want to cut it about there where I've made that little crease. Then we'll have our negative tab formed, so it's double layer of nickel, and that should be quite painless and plenty strong enough. Just like that. Okay, nice strong weld, nothing's moving. Can't rip it off. Fold that over out the way. And then we're going to have our group here. And then our group here, and then a long one, then our group here, and then 4 by themselves. So I need 2 of these cut off, and I don't need any of the tabs on it. So one's going to go there. Come back here, you. That one, and we're going to need another one of those, and one of those. Okay. Trying to do it slowly like this to give the caps a chance to charge back up. Yep, we definitely do want to be putting that there. You've got to watch out for these stray bits of nickel that fly everywhere, and when you're cutting the tabs, really should be cutting them elsewhere. Because if you put the pack down on there, it could short it all out, which nobody wants. Oh wait, no, I'm an idiot. I've cut the wrong nickel. Like a fool. Don't know how I managed that, but I picked up this other one. Of course, it looks almost identical. Never mind. I shall try this again. Oh, it looked different. It's going to go there like that. Doubly. Hopefully you're all in frame nicely and you can sort of see what I'm doing. There's that one. Hopefully, I like to just check and make sure that we don't have any loose welds in there as I go. Oh, I forgot to say, I'm building the pack with LG MH1 cells, which are very kindly provided. I say provided, I bought them at full whack with absolutely no discount, but you know, they're a good supplier, by cellsupply.co.uk, who are fantastic and super duper helpful. One of those. Make sure it's vaguely the right length before I cut another one. Oh yeah, it's all good. Move over, you bugger. There we go. There's one of those. I'll need a second one of those, but I have to let the welder charge back up a little bit before I start doing that. And it's going to cut to about there. Vaguely straight. And then we're going to need another 4. Yep. Make sure none of those are getting close, creeping towards me battery. Go on there like that. The reason I'm not doubling these up is because from the positive to the negative, or negative to positive, whatever you want to look at it, is a series connection. So essentially there is where all the power for the entire pack has to flow through at some point. And that's a point where it can get hot, or well, it would have the highest resistance if it were layered up only singly like that. And on these, from the positive to the negative, or negative to positive, whatever way you want to look at it, this has 1, 2, 3, 4 connections already. So that's why I don't double those up, because you don't need to, or at least for this battery you don't need to. Of course, if you're doing higher power stuff, you've got to start thinking about a lot more things. But on a nice little 36 volt battery pack like this, which is it's a lot of what I do, is reselling 36 volt batteries for customers. I live in a little seaside town where a lot of the population, they don't want big, fast, crazy electric bikes. They just want street legal electric bikes that get them from A to B. And some people have mobility issues. Lots of the population around here is elderly, and if they're riding their bike, some of them can't pedal anymore. Only older bikes in the UK, so I think it's 2018 they changed the law, and prior to that, can have a twist throttle in the UK that's de-restricted. There are ways around it, and you can get some type approved by the MVSA and stuff, but it's a right faff for the average consumer that just wants a bike that they don't have to pedal if the legs hurt, or if they just want to go up and down the seafront, they don't want to pedal. There's a limited way to do that legally in the UK here. So keeping the old bikes on the road is actually a surprisingly large thing, because you can't go out and buy a new throttle bike that's street legal easily. What else are you going to do? You're going to keep your old one that's got a throttle on it going. Now, I don't quite know how the law works with such things, because let's say the battery dies and you replace it or resell it, and the motor dies and you replace it, or something like that. Say it burns out or cracks or something, and then the controller breaks and you're left with only the frame. At what point is that considered a new bike? I don't know the answer, and it's a difficult one. I don't make the laws. I'd imagine it's probably tied to the frame and power rating of the product, I think. Right. Our final piece here then is our main positive terminal for the pack, which I think, trying to work out what way I wanted to point. If I wanted to point that way out or that way out. It's a difficult one, because I know we're limited by space in our pack. I'll tell you what, let's try and pop it slightly in the case and check out what way fits best. That way we're limited by space, but not down there. And that way we're limited by space, but then not down there. Okay. So if I had it coming out along this edge, that would be absolutely fine, because we do end up with a bit of space. So I think that's what I'm going to do. Then all the wires can run nicely and neatly. And then the only bit I am going to double up is for our main positive out, which I'll probably put right at the end of the pack here. I'm going to just add another little layer of nickel on top of that. That's just so that nothing gets hot. I think technically you can get away with just using one strip of this 0.15 nickel the whole way around the pack. However, I don't want to, so I'm not gonna. Right, we're done with our main spot welding now. I've just got to sort out the rest of the balance leads, or balance tabs, should I say. And I'm going to put this one here. On a 36 volt battery, I am significantly less likely to get electrified by anything. See, I can touch the positive and touch the negative there, and I'm not all jolty and zapping. Because touch voltage is around 50 volts. Obviously it varies if you've got oil or contaminants or something like that on your skin. It's not going to be the same, so I wouldn't take that as gospel. That's what they sort of consider general safety extra low voltage in the UK. So it takes normally a voltage of around 50 volts to break the resistance of one's skin, which is why I'm not getting electrocuted touching both sides of this fully built pack. Sorry, electrified. Electrocuted is the act of being killed by electricity, I believe. When you start working with 48 volt packs, they are discharged at around sort of 40 volts, so you could touch a discharged one. Not that you ever should, but theoretically you could touch a discharged one and not have that many problems. But then if you touch a charged pack at 54.6 volts, quite likely to give you a zap, which you won't enjoy. So, as always, don't do any of this. It's all, I'm doing it so you don't have to, etc. Right, there is one of those. I can turn off my spot welder and we can have blessed silence. which is just fantastic. That's what we always wanted, isn't it? Okay. Now we've got to start thinking about the BMS and wiring for this pack. So I've got here the innards, the gubbins from the old one, and it will sort of end up sitting a little bit like that, but obviously it's going to have this around it like that, so that's going to go in there. So what we want to do is get this wired up so it all works. I think I went through in the first bit about what the different wires did, which is no biggie. There's nothing too crazy or confusing going on there. Fairly easy things, and the key switch on this is it actually cuts the power, so I can get away with using the most basic bog standard normal BMS, which is nice. I'll grab one of those now. Okay, so there's one of those. It is 10 amp, 10S, 15 amp, 3 MOSFETs, and it does what you want a BMS to do. Separate charge, power and battery ports, and nice long balance leads to reach anywhere we want it to in the pack. So, if I planned this right, it would fit in the case. Did I think about that? No. Of course I didn't. We might struggle a touch. We've got a bit more room that way. That's probably the way around we're going to have to go for it. It's a bit ugly, unfortunately. If I do it that way, we're going to make the most sense, I think. Something like that. Then all the leads can come around where they need to go, and I'm not increasing the width of the pack sideways at all. I think I found my answer. What I normally use to stick these on is a bit of double-sided tape. You can get it in thicknesses that pretty much almost exactly cover the thing, which is great. So I want to cut that just about there. The red side is generally more difficult to peel off. Do that, I can stick that onto the BMS itself, just like that, and then do it that way. So what I might do is chop these off. I think I will. Okay, that should give it a bit more of a flat surface to stick on. Better. Lovely. That's stuck nicely. If I can pick up the whole pack with it, I'd say that's stuck plenty well enough for me. So what we want to do is get the balance leads wired up. Now how that's going to work is the first one here, so our main negative, takes the black lead here. So I'll get my soldering iron turned on. Move some of these bits out of the way. And then this lead needs to go to the balance tab I have left over here. I might do the main negative connection first, because then I can cover it in barley paper and have it be gone out of the way. That's what I think I'll do first. So, have I got a bit of cable anywhere remotely close by? No. Of course I haven't. Why would I do that? Too sensible. Too prepared. I do actually. Right, so this is only going to have to go from here to there somewhere. So around that long is perfectly adequate. Great stuff. So I might pop this end on first. A bit like that. Excellent. My sticker solder. Might as well do all these three while I'm at it. Tin this bit of wire. That is nice and hot. That is nice and hot. Bloody hell. That part, and then tin this end of the wire, which thankfully is already sort of getting up to temperature, which is lovely. A little pair of pliers to hold that because it's very warm. Drop everything. It was a good shout. Okay, it's more like it. Right, so what we want to do, we want to be insulating around all our connections. Technically this negative to that won't make a difference because it's all the negative outer, but for good practice we want to go through it all. I'm going to cut myself a bit of barley paper here and peel the backing off it first, otherwise I'll be peeling off 1,000 very small and irritating pieces of backing, and this way only got to do one. We'll get ourselves a piece for underneath the main negative. That's still quite hot. There, and then we'll want a piece for over it because we want to insulate this connection from everything else and not have it annoy us or short anything out. Just like that. Lovely, that'll keep that nice and out of the way. And then we're going to want to do the same for all of, well, underneath these doesn't make a difference, but do any even go close? None even go close. That's fantastic. I will save that for in a minute. Right, I'm going to tin my balance tabs with the iron first. It's going to make life easier. Missed one. Flip her over. Do the same. There we go, lovely. Okay, so our first lead is going to go to our battery if you're negative up here, I'm a big fan of keeping the leads the same length throughout. So I would rather there be a big ugly bundle of slack somewhere to there, because what that does, that keeps the leads having the same resistance. Some people don't like to do it that way. Some people like to make the world's neatest and prettiest pack, so you know they'd have it all cable managed down there and then it would turn directly in. I'm of the opinion that a functional pack is often, not always, but often, can be better than, oh, I open it up and it looks like it was made by Apple or whoever made, you know, very pretty things. That's my opinion on the matter. It doesn't have to be the same as yours, but you know, I have a reason behind that. And when I know it's only a short run, but when we're talking about very, very thin wires like this, I'm not going to do that. A very, very thin wire like this, it does actually make a little bit of difference. Not huge, but a little bit. So there's one there, and then we're going to go over to this side, which is the other side of the cells. I'm going to stick that down. Stick it down, solder it on. Same thing. And we will be able to get these looking vaguely neat. You know, they'll all be in between here, held on sort of, you know, flat like that. After that then, the pack goes, where does it go? Into this group, and then over, we're going to want to flip the pack over, to this group of cells just here. After that, so we're at that negative there, we follow it and it goes through, oh look, to this pack here, group, sorry. So we're going to take our next balance lead and we're going to do the same thing. Then we're going to go to this one. Nice and simple. Don't see the point of making a complicated pack. I would rather go for a simpler pack design in the first place, spend more time thinking about how you're going to put it together, than struggle when you're doing it. Because when you're doing it, it's a bit stressful, because you know, essentially you're handling a small bomb, and I would like to be the least thinky, if that makes sense. So I'd like to put the least brain power in as possible when I'm handling said small bomb, to make sure that I don't do anything silly like electrify myself, burn myself, set fire to things, you know, all that fun stuff. So we go through there and then through the cells. So we're now up to this balance lead tab just here. I'm going to get our next one. It's going to come round like the others did, and it's going to join to this tab just here. And then we'll look where the cells go. Done that one, haven't we? Yep. So through the cells and up to this one just here. So for a 10S battery like this, you've got 11 wires. Which is only slightly confusing. And then after that, goes over to here. So we'll get the next one. Pop them on there. So we've got no more balance tabs on this side of the pack, everything's on the other side now. So we're going to go for this one, and we've just connected to that tab there, so that goes through and then over to this one. Then we've only got one more white one left, so it has to go over here. And then our main positive, balance lead anyway, it's going to just go to there like that. Nice and painless, and that's our balance wires complete. Obviously they need to be tidied up, I'm not just going to mush them on, but they're connected at least, and you can go through with the multimeter and verify that they're all adding up on the balance plug, as they should be. Try and figure out a way to do a little bit of tidying on these. You know, I might even make them tidy there and add the slack on top of the BMS. That might be the neatest option for this one. I think I'll do that. Alright, I have made this prettier, so we've arranged the balance leads vaguely nicely. Bundle of slack is up the top, tied together with a cable tie, just slapped to the top of the BMS to completely destroy its heat sinking capabilities, because I'm a genius. Anyway, now what we need to do is we need to get the all the leads hooked up to where they need to go. So we've got, on the negative side, we've got our why are they all going through there? I don't like that. It doesn't make me happy. Be going through the right side. Ugh. Whose idea was this? It's all tangled up here. Is that better? No, it's worse. Oh Lord help me. Is that better? No. I can't win. Right, I fixed it. Okay. So, standing the pack on its end, we've got our main, this is power to the little board on the top, the battery indicator, and this will be our charge negative. So the one that we can do right now is the charge negative. And that goes to C-, handily labelled. So I just need to tin the end of my piece of wire here. Oh, that's very, very hot. Oh, it's very, very hot. Right. And then we've got our power minus and also this power minus. They need to go together. Get off me. So this one I'm going to strip a little bit longer. And this one I'm going to strip to a relatively normal length. Probably a bit too long, but I can chop the end off. And then I'm going to wrap this one around this one before I solder it. And what that's going to do is let me solder both at once without using the helping hands, because that would make my life too easy, wouldn't it? Just like that. Somewhere good I can balance that isn't, you know, like on the battery pack. Yes. Bit weird trying to get everything in view of the camera and not have the back of my head in the shot. Normally I'd be right up close, it'd be about that far away from my face, so I'm doing everything almost at, not quite at arm's length, but further away than I normally would. So it's different to give me a bit of leeway there. And we'll get that soldered onto the main power out. There we go. Now, This will all need obviously dressing nicely and stuff as we go, but that's fine. And then our positive wires, got these two here, they're going to run down the side of the pack and get hooked up to, it really wants to be that way up, doesn't it? Yes, it wants to be that way up. And they're going to get hooked up to down here. So one of these is our charge cable and one of these is our main power cable. They don't actually need to be on separate pieces of wire, but they are, so I'm going to keep them like that. This is not a normal bit of wire. But that is. So, are you long enough? Oh, look at that, you're plenty long enough. That's fine, once there's actually quite a bit more slack in there and a bit of room, so that's good. Let's get this one tinned. So the balance wires being pressed up against the side of the cells aren't a problem. They'll carry, what, 5 amps in the case of a short circuit, and just fizzle out into nothingness. Not a big deal at all. These larger gauge wires, absolutely, you do not want them running up the side of the cell because they will not short out as quickly. You know, balance wires are almost like fuse wire. What you do want to do is keep them separate, which is why there's a layer of Kapton tape here. Then they'll go on, then they'll be taped down. Everything's all gonna, you know, the pack's gonna be dressed when by the time we're all finished. And then our main positive wire here. That's the discharge positive. Get that all done, and then get that soldered in place. Just like that. Hot, 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 hot. Ah. Underneath these is going to go my piece of barley paper from earlier, because we really don't want these ones shorting out on anything. That's obviously not a good thing. I suppose I could do this side now while I'm at it, couldn't I? Yeah, I think these wanted to go that way. That way? Be fine, it won't make much difference. I'm just going to get a nice long bit of Kapton tape to hold them all in place. Stick them on down. So, theoretically now this is a working battery pack with discharge wires, and something isn't right there, is it? I'll have to sort that out. Theoretically this is a working battery pack that should, there you go, show output voltage and then take a charge. So this is the point that I would test it before it goes into its case, because if there's a problem, obviously I don't want the pack to be fully dressed. That'd be really annoying if you have to take it all apart. So this is the point that I'll fully charge it, test it, and so that, when I say test it, I mean capacity test it. This is the customer's charger. We've got a red light and a green light, and that one I think should turn red when it's charging. But yeah, I'll capacity test it now. There we go, and it's charging. Fantastic. Let that fully charge, and we'll cut back to things when I've finished my testing, made sure it works properly, it holds the capacity it's supposed to hold, if nothing gets hot, the nickel stays, you know, fine, doesn't deform, come off, anything like that. Then we can dress the pack, fit it into the housing, sort out that I put around the wrong side, and then of course retest again once it's all back in its housing and we're happy that it's ready for the customer. Okay, right, much has happened. Battery tested, all is good, all is well. I'm not going to bother letting it fully charge again before I put it in, that's fine. If it's tested, it will be okay. What I've done is I have wrapped the pack up in barley paper like that. Now there's no, what do you call that stuff? Come on. There's a name. Battery fibre board down the sides yet, because we're just going to look at clearancing. I didn't really want to put the whole thing in the case first, just because danger. So I think we should fit that way. Oh, look at that. It's beautiful. It's beautiful. Oh, it's beautiful. Look at that. And it all fits. If that's turned around the right way, of course. Yes, look at that. It all fits. Wait, no, that's the wrong way. Aha. The more you know. Hold on then. Now it all fits. And then that is round the correct way like that. There you go. Right. Just like that. So, what I need to do is, I was just looking at where I've got room to run the cables, and down this rear side here, lovely gap. And down that side there's a lovely gap. So, I think I'm fine too. Sorry, I'll just punch the camera. Run these two down there somewhere. A little bit like that. Something like that I think should work nicely. How am I going to get that to stay while I get the big tape out? Grow extra hands. That's what I need to do. It's going to go without tearing? No. Of course it isn't. Why would it do that? Make life too easy. Get off me, please. Alright, there we go. One of those on there, like that. Let's make sure that fits again. Lovely, loads of room, nice and happy, fantastic. And then I need to attach a bit of fiberboard. I did have this, which turns out is exactly the size I need, so I'm going to use this. How convenient. There's one. There's two. Normally I'd reuse what came out of the battery, as long as it's in perfectly good nick. There's absolutely no reason not to, because ultimately it's a piece of, well, it's not quite plastic, but it's a bit like a piece of plastic. It doesn't just go bad or anything. So that's what I would normally have done. It does seem to fit in there nicely, but I think what I want to do is just trim it down, maybe. How far does that line up to? Yeah, a little bit. Now let's trim it down to sort of there. There you go, that fits better, doesn't it? Lovely. Height-wise, just trim off about that much. Yes, lovely, lovely. So this tape's only got to hold it in place until my heat shrink is on the pack. There's no point wasting super expensive Kapton tape. For the sake of holding it for a few seconds, might as well use cheap electrical tape. And then this one we'll trim off a similar amount, I imagine, about that much off the top. There you go, bang on. And then most of that there, look at that, it's a perfect fit. It's what we like. One, two, and then we got a bit of foam that lives on the bottom. It was all stuck on beforehand. These parts, I did some reconstructive surgery on these, so that's glued back together, loads of nice glue on the back of that, and then this little one is glued back together also. That has got to pass through all that lot so that can sit happy and nice. And what we want to do now is shrink wrap it. It's not very exciting watching me shrink wrap things. All that is involved is me selecting an appropriately sized piece of wrap like this, sizing it to length so it's to be a little longer than your pack, somewhere around there. Cutting it to size. Sliding it over said pack. Like that, getting one of the corners, or two if you possible, lined up with the corners so you don't end up with the corner on a straight bit, which is boring. And then finding a fully charged heat gun, in my case, or you could use a mains powered heat gun, of course. This is just convenient. The DeWalt batteries that I use, they're all charged from my solar setup, so it's free. And my solar setup, we're in England, so it's a bit pants, and it won't charge, it won't run a mains corded heat gun for very long. I split the wrap. That's okay, this battery can have two pieces of shrink wrap. You can double up. This stuff's a new roll that I've only used once before from a different supplier to where I'd normally get it, and I don't think I'm going to be using it again. It feels thinner than the the shrink wrap I'd normally use, which tended to be a bit thicker. I got the original shrink wrap, I think it was from Fogstar or 18650 UK. Cell Supply or whatever they want to call themselves now, and it seems to be a much higher quality product than this. This was, of course, from that one website that rhymes with AliExpress, and yeah, I thought last time I used it I put a hole in it really easily and I had to use two pieces, but I'm wondering if now it's because it's a thinner product I can't apply heat sort of the same way as I'm used to. The shrinkage there isn't great either, it's not even fully covered. Oh look, we've got another one there. Yeah, well, he's getting 2 bits, isn't it? I think that answers that. To make it look pretty, because shit. I mean, pants, bad looking, not excellent-ish. Right, so that in there, just for making sure purposes that everything fits. One of those wires in there. Put that in there, and then there's that. Yeah, we should be good for fitting, I believe. Fantastic, lovely. Right, I'm not going to bother doing anything else on camera because you've seen all the exciting stuff. What else? Not really a lot else to do. Just go through another round of testing, make sure it all works once it's back in the case and everything. Nothing, nothing's moved or anything like that. Then I'll call the customer and tell him, "Oi, your battery's fixed. Pay me, please." And we'll go from there. Thank you very much for watching. If you like this kind of thing, you like the longer videos, maybe showing the full process, please feel free to leave a like, leave a comment, subscribe, become a channel member. It really helps. Well, it doesn't really help. It helps a tiny little bit. I think it's 99 cents a month, and I end up with a shockingly small quantity of that. Anyway, it inspires me to keep making these videos and helping people out, because I understand some people might just want to bring their stuff to me, but some people, they might be overseas, they might want to see how something's done. Maybe they got one of these batteries and they just want to know what's inside it. Anyway, yeah, thanks for watching, and I'll see you next time. Bye bye.